Hey you guys, welcome back to the channel Physics Surgery, and we are here in Resolved series, and I've brought forward a less discussed topic, especially in NCERT textbooks and all these, where they give those questions but they don't give the kind of text that is required to tackle these kind of issues. Okay, and often students find it difficult to answer them in the JEE level examination, both JEE mains and JEE advanced. Okay, so these are dependent errors. So on the board you could see that we have taken a measurement R is equal to P by Q. Then the fractional error or percentage error in R should be write it as sum of the percentage errors of P and Q, or subtraction, or is it neither? Okay, so we'll try to take two illustrations, and please do stay till the end of the video because I would be giving you a practice problem which will also add on to the concepts that we will learn in this particular question. So that would be equally important as the two illustrations that I'm going to provide you with. Okay, so let's go ahead with the problem statements. So these are the two problem statements I shared with you in the community post also. Just in case you missed them, I would request you to actually pause the video here, try these two out. The first one is one or more than one correct type, and the second one is the integer answer based type question. Okay, so and one thing's for sure, once you're doing these questions, there'll be a lot of things that would get clarified in the concept of error analysis. Okay, right? So I'll go with the first question. In an experiment to find formula F is equal to UV divided by U plus V, where U and V are measured quantities as follows. U is equal to some measurement, V is equal to some measurement is given, and he has given four questions. One is about order of magnitude of U, second one is the number of significant figures in V, and percentage error in U plus V, and percentage error in the F, right? All these are nearly calculated. Okay, so we'll start with the first question because there are multiple concepts. So first I'll start with the concepts required to tackle this question, and then we'll solve the first question, and then we'll move on to the second one. Okay, right? So you want to give it a pause here, just make sure you do it and then follow my lead. Okay, so here's the concepts that are involved in the question. So we will try to first of all address something that is very basic, and then we'll go on to the question. Okay, usually when we have R is equal to P by Q, where P and Q are measured from two different experiments, very important, the errors in them are independent. Okay, so they are independent errors when they are from two different experiments. Obviously whatever error you obtained in measuring P need not interfere with the measurement that you did for Q. Okay, so in that, when you use the calculus and write ln of R is equal to ln P minus ln Q and differentiate it for small errors, dr divided by R would be equal to dp by P, and then you put a plus here. The reason for putting a plus is always we try to establish the maximum possible error. Whenever you write a quantity, for example, I'm giving you, let's say P is 20 plus or minus 1% and Q is 10 plus or minus 2%, let's suppose. Then what is this plus or minus mean? Plus or minus means it's a random error. So whenever you are reporting random error in a measurement, okay, with R equal to P by Q, you want to estimate the maximum possible random error. Always you are trying to convey to other person that this could be the highest possible error when you are taking the manipulation of R. Remember, R is not being measured. R is being computed from the measurements of P and Q. That's why you have to be on target with the highest possible value. So the highest possible value, I would say, could occur when the positive error of P collides with the negative error of Q. So if the positive error of P and negative error of Q are taken, then you'll end up having the maximum possible error. So some textbooks actually put a mod also, and that would be a better way of stating things. I didn't put mod, but that's obvious. Okay, so the plus is chosen, and you're allowed to choose because you can incorporate maximum possible error in R by choosing an event, a one particular event where your dp is positive and dq could be negative. There's a chance, right? You can always arrive at that kind of a situation, but this shouldn't be applied carelessly for P and Q being dependent errors. That is, when error in P is related to that of Q. Imagine this P and Q are related to each other. They are not two separate measurements. They are supposed to be part of the single measurement, or let's say a measurement in P affects the measurement in Q, then you should not use this logic. Okay, and that is where the first question steps in. Okay, so let's try to see what that first question is. In the first question, if you carefully observe, he says the formula is UV by U plus V, And if I say uv is p in the numerator and u plus v is q in the denominator, we cannot write that previously written thing, because you realize the u and v, which are measurements, uh, this itself, whatever measuring values you are taking, let's say positive error in u, positive error in v and all that, the same signs of error will also come in u plus, because you could see that they are functions of the same measurements. Okay, so you cannot say the error in p is not going to affect the error in q. The way you chose your errors in u into v will also affect the u plus v. That's why you cannot write this directly. Okay, so in such cases, for small errors, we rely on calculus. That's the best way to go about business. Okay, but after reducing the formula to independent measurements, you don't want directly to apply the calculus here, because on the numerator and the denominator, you do have dependency. So you make them independent and then differentiate. Okay, so here u and v should be independent. Okay, so u and v are independent, but p and q are not. So write them separately in terms where u will not collide with v. So that's why we write, not because this is our famous formula. I have taken a famous formula here, but in general, if we let's say gives a different looking, unknown looking formula in an exam, try to always manipulate it so that the terms are separated out. Okay, right? So then you differentiate. This is basic calculus, and then you want percentage error. It should be df by f, right? So one of these f, you send it on to the other side. So can you see, I can write this as du by u into f by u plus or minus dv by v into f by v. Now I can state that it should be a plus, because these two are independent terms. Okay, the effect of u will not be seen on effect of v, and when I multiply with 100 on both sides, all these fractional errors become percentage errors. So I'll just copy this and borrow it into the next page so that we can forward our solution. So I have written that one here. Oh, lot of things on the board. Okay, so just don't get frightened. I'll just take you through, and all these numbers will make a lot of sense once you listen to me very, very carefully. Okay, so also I have borrowed the values of u and v from the question and made the value of f, the direct calculation wise. And remember, I need f by u and f by v, right? So I also manipulated f by u is 1 by 3 and f by v you can clearly see is 2 by 3. Keep these things aside in your mind. Okay, now given this entire measurement is like this, remember 8.0 plus or minus 0.2, I would love to convert this into percentage error. What is 0.2 as a percentage of 8? It's 2.5%. So I just wrote the same thing all over again here and wrote it as plus or minus 2.5%. Okay, and same thing I did with v. I arrived at this 5%. Okay, right? Then now I'll write q and p just to illustrate, okay, why you should not convert them into q and p. Okay, so let's say the denominator u plus v, I'll write it as q. So what is u plus v? You just add 12.0 plus or minus, the absolute errors just get added up 0.4. No issues, I think. Again, same logic I'll do. I'll convert this into a percentage form. The 0.4 out of 12 is a 10 by 3%. I wrote it in a fractional form. Okay, then p I define it as product, and in product I don't want to directly multiply this. I'll do it from the percentages. Okay, because I think you all should understand that in a product rule, percentage errors get added. So 8 4s are 32. I just wrote it directly, and 2.5% and 5% in product becomes a 7.5%. This is another rule of its own that you should know for JEE Advanced. Okay, right? So with p and q's percentages known and u and v's percentages known, let's go ahead with all the three possibilities that come to a student's mind. Okay, first let's go to the wrong possibility. Okay, so if I want to write f is p by q, f is p by q, right? uv divided by u plus v, that is p by q, and I put a plus sign thinking that they are, let's say, independent errors, and I go about my business. What is dp by p? That is a percentage error in p, right? 7.5. Can you carefully observe here? I borrow this 7.5, wrote it as 15 by 2. And dq by q is percentage error in q. I end up having a 10 by 3. I wrote it like this. So the summation of these two, let me move up. Okay, summation of these two is going to give me 65 by 6%, which the examiner, which was me, wantedly gave that so that students fall into the trap of marking 65 by 6%. Okay, right? Whereas here, df by f, now what we are doing here is correct, but it's not recommended. The reason is I'm putting a minus itself here, as I can assure you in this particular problem that if you have a p divided by q, then if I choose positive errors in both u and v, then I can't choose negative errors here in u and v, because once I choose an event where I have u as positive and v as positive error, then u plus v also you're simultaneously choosing. You can't say this u is different from this u. Therefore, when you do the division, you actually get a subtraction because they're dependent. And that's why 15 by 2 minus 10 by 3 should be done, and not 15 by 2 plus 10 by 3, and you end up getting 25 by 3. And I won't recommend this because I'll give you another examples later on, in which your minus also will fail. So plus is definitely wrong. Minus here is corrected but not recommended, because I'll just shatter your belief in this particular way of doing by giving an alternative method, where if you choose a plus here, you can't choose a plus here. I can manipulate this particular things into a different formula later on. Okay, right? So this comes out to be correct. 25 by 3 is correct, and I can prove it to you in the actual method that I wrote right at the top. Whatever I wrote, I just borrowed it here again for your convenience. And this, if I substitute, what was the du by u? Du by u was 2.5%. Can you see this 2.5% du by u? That is 5 by 2. F by u is at the top 1 by 3. dv by v is this 5%, I just substituted, and df by v is 2 by 3%. So you can see that these two actually match. And this, I would say, is the most recommended method. Whenever the dependent errors are given, just make them independent by separating them out and writing the terms which are independent of each other, and then perform calculus. That's the best way of arriving at things. The middle one might give you a correct answer in some cases, and it won't in some other cases, because you can't be very clear about the type of errors that they are related to. And since they are related to each other, this is definitely wrong. 65 by 6 is definitely wrong. Okay, so let's move forward to the other options here. And in the first and second option, he talks about order of magnitude and significant figures, which are also important as per your NCERT textbook. So in this particular scenario, I just wanted you to get a revision of this. So if I have an Avogadro number kind of a thing, then the order of this thing is nothing but this 10 power 23 is usually thought of, but it's not. Some of you might be already knowing it. For those who are new to this, you should always look at the scientific notation of this, which is like writing one digit, a point b c d kind of thing. Okay, this a should be not 0. So this is called scientific notation. In that scientific notation, if this number is more than 5, then this number is closer to the 10 as compared to 1, right? So the order actually of this is 10 power 24. And what is meant by order of magnitude? The power in that order is the order of magnitude. Okay, you should know this. For example, if I take Stephan's constant 5.67 into 10 power minus 8, which is a very nice number, 5, 6, 7, and 8, right? In this scenario also, this number, it is 5, but this number is more than 5, right? This entire number is more than 5. So this power has to be increased by 1. Minus 8 has to be increased by 1. So therefore, order of magnitude is minus 7. Don't take magnitude of that. Order of magnitude is a name. So minus 7 is the answer. 5.0 into 10 power 3, if it's exactly 5, you actually take it closer to the left side and not the 10. Okay, it's closer to 1 and not 10. So it stays as 3, and this is something you should remember. Okay, it could have gone either way, but the rule says it should be 3. Whereas in the given question, u is 8.0 into 10 power minus 1, right? When you're taking the order of magnitude, you don't take the error. You're talking about the actual measurement only. So since 8 is closer to 10, this power has to be increased by 1. So the order of magnitude is 0. Order is 10 power 0. Okay, right? And v, he has asked significant figures. You should understand he talked about significant figures in centimeters, whereas he asked order of magnitude in meters. You realize the powers of 10 will change when units are changed. Therefore, order and order of magnitude depend on the units that you are mentioning. But whereas significant figures in scientific notation will never depend on the units that you are using. Units will only change this number and will never touch this one. So significant figures are actually 2 in this, and independent of units used. So order depends on units, whereas significant figures don't, is a very important aspect that you should know. And please do read NCERT. There are 2 or 3 pages of this that are very important for your exam. Okay. Let's move on to the second question. So the answers for the first one, let me mark before we forget what we did. Right. So order of magnitude in U in meter is 0 is a perfectly correct answer. Number of significant digits in V when measured in centimeter is 3 is wrong, because there won't be any change. So percentage error in U plus V is 10 by 3. We got that 10 by 3. But the last one is definitely not right. 65 by 6 is wrong. I think I ended up getting 25 by 3 if I'm calculating correctly. Okay, so that's the required answer. Okay, right, I think it's 25 by 6, I guess. So I made a small error here, so this should be 6, and here also it should be 6. Okay, right, so let me go back. Yeah, this is 25 by 6. Anyway, 65 by 6 is definitely wrong. Right, so let's move forward. Check the calculations. Okay, right, so the relative density of a material is found by weighing the body first in air and then in water. The weight in air is found to be 10.0 plus or minus 0.1 Newton, and weight in water is found to be 5.0 plus or minus 0.1 Newton. From this, maximum percentage error in relative density of the body is found to be dash percentage. Okay, so I want to give it a try. Try to first of all understand which formula you are supposed to put up in the buoyant force section, and then how to use the dependent and independent error. So I think this would be very nice practice for you. Okay, so I'll move forward with the solution. So I'll just take down the important numbers that he has given. Weight in air, I'm calling it as capital A, okay, right, which he has given as this number. And weight in water, I'm calling it as W, which is this number. I think relative density is equal to weight in air divided by loss of weight, right? That's the idea of buoyant force, okay? So A divided by A minus W, if you do the manipulation of 10 and 5, 10 by 10 minus 5, the value is 2. But I have to do the error analysis now. But if I want error or percentage error in R, I realize this is a P and this is a Q, but where P depends on A, Q also has a dependency on A. So that means I could say this numerator and denominator are dependent on each other. So you can't just recklessly do your original rule that I started off with in an independent case. So I'll be very, very careful here, and I'll try to rewrite it in the independent parts. Okay, so first I'll realize that I can write 1 by R, A minus W by A, and then I separate things out so that I have two terms which are independent measurements. So these two, when they are given separately, you should believe that they are separately measured. Obviously, you have used two different measuring techniques. Okay, right. So W by A, which are independent now. Now use the calculus. Okay, right. When you use calculus, 1 by R already differentiated gives you dr by r square, and one will just go off, and differentiation of W by A is this normal calculus, and there is a minus here, right, actually in calculus, whereas I put a plus. And why is plus chosen? And you are allowed to choose plus because now these two are independent of each other. Whenever they are independent, you try to choose the maximum possible error. Okay, so you just rearrange. You want dr by r, remember, fractional part. Bring one r onto that side, just take the LCM parts here, separate out, and then substitute all the required numbers that were given. Okay, so R was 2, and DW here you could see is 0.1, A is 10. Properly substitute all the possible numbers and rearrange, and if you do it correctly, you get 3%. And if you just make a mistake, the numbers I have arranged here in such a way that you'll also get a 5%. And in case you got 5%, now you know what mistakes you could have committed. Okay, right? So this is another important question where calculus saves the day. Okay, right? So I hope you're now ready for the practice question, which will test your understanding of what I taught here. So this is it. I'll be taking up in the AITS Select series. This is from one of the old China papers, China AITS. Right, so just take a snapshot, have a go. It's an Atwood machine, so it's not much about the physics of the problem, it's more about the error analysis. It's talking about the maximum percentage error in the calculation of acceleration of blocks. Okay, so all the best with this. I'll come up with a solution as soon as possible with this. Okay, right. So in case you want to see rest of the resolved series videos, the link of the playlist is in the description below. And also the other series that have been already put up, and more than 100 quality videos in this channel, spread across different forms of series. All those links of the playlists are in the description below. So please make sure you have fun with those. Okay, so in case you like the explanation and the video and also the past content, please do like the video so that it can spread across the YouTube algorithm. You like more and more videos, the YouTube algorithm starts recommending that video to more and more people, and that's how the channel spreads. Okay, so I hope you can help me in that regard. Okay, and do share the content with your friends and try to request them to see the quality, and then please do subscribe to my channel. In case you are new, I would recommend you to go through at least 3 or 4 videos, and you will definitely understand the quality that is presented in this particular channels that you would love to be associated with. Okay, also press the notification bell icon, because nowadays I'm producing videos at intermittent times, because I'm very busy with my students who are also giving JEE mains and JEE advanced, and I would love to produce more videos, but it's very good if you can get the notification whenever I do that. Okay, so I'll try my best to keep up with the pace that is required for your practice for your JEE advanced exam coming up, and let's hope you stay with me in the next video. Okay, thank you and see you soon.